Okay, so looking at different laws, the different examples, I'm sorry, of Dalton's law. The pressure of a mixture of nitrogen, carbon dioxide, and oxygen is 150 kilopascals. What is the partial pressure of oxygen if the partial pressures of nitrogen and carbon dioxide are 100 and 24 kilopascals respectively? So the pressure of a mixture, so this is my total pressure, and I want to just find what oxygen is. So you should be able to figure out that you have to take the total, subtract 100, subtract 24, that will give you your partial pressure of oxygen by itself. So this one will be 26 kilopascals. As long as the units are consistent, you're okay. However, if I ask for you to convert, then then so be it. Noble gases are mixed together in a 10-liter container. There are 3 different gases and 3 different pressures in the unit torr. What is the total pressure? The 10 liters is extra information. Not meant to confuse you, but All right, what is the total pressure? So all you got to do is add up these numbers. 285, 488, and 50. Okay, so then the pressure is going to be 823 torr. Total pressure of a mixture is 930. I'm sorry. I give you 2 partial pressures. I want to find the last one. So then total pressure is 930, so minus 40 minus 230. So then your answer is going to be 660 millimeters of mercury. Dalton's law implies that each gas in a mixture acts independently of the others. The total pressure is related to the moles of gas in the mixture. So I can add up the total number of moles and I can figure out what the pressure is from this. So a mixture of 0.25 moles of carbon dioxide gas and 0.30 moles of oxygen gas is in a 10-liter container at a given temperature. What is the partial pressure of CO2? What is the partial pressure of O2? What is the total pressure of the mixture? I'm sorry. On your notes, I flipped the questions around, so if you're going to go over the lecture, please follow this order, okay? So let's do letter A first. So we're going to focus on moles of CO2 for now. So we're trying to find the the partial pressure of CO2. So PV equals nRT. Divide both sides by V. 0.25 R 0.0821, temperature 298 Kelvin, divided by 10 liters. So 0.25 times 0.0821 times 298 divided by 10. So my pressure is going to be in atmospheres. So this is going to be 0.61 atmospheres. So this is the pressure of CO2. Letter B, what is the partial pressure of CO2? So I changed it to where I specified that it's CO2. So NCO2 0.30, 0.0821 times 298 0.3 times 0.0821 times 298 divided by 10, 0.73 atmospheres. Sorry, this is pressure of O2. My bad. So this is my answer for B. This is pressure of A. So I add these two up, 0.61 plus 0.73. Total pressure, so letter C, 1.3 atmospheres.